Graphing polynomials. Okay, let's see how we're going to graph the polynomial right here. F of x equals x plus 1 times x minus 2 times x plus 5. So we're asked to find the x-intercepts and the y-intercept. So for a y-intercept, we know that x needs to equal to 0. And for an x-intercept, we know that y needs to equal to 0. So we're going to set f of x equal to 0 and rewrite the equation. To find the x-intercepts, we are going to use the zero product property. Where we set every factor equal to 0. So my first factor is x plus 1, set it equal to 0. My second factor is x minus 2, set it equal to 0, and x plus 5 equals 0. Then solving for x for each one, we subtract 1 here on both sides, so we get x equals negative 1. That is a 0. We also call it a root. In this case, a real root. And on the second factor, we have x equals 2. And here we have x equals negative 5. So we have 3 real roots. Now let's plot these 3 x-intercepts, also called roots, on the x-axis. So we have an intercept at negative 1. Okay, let's see how I could do this. Negative 1 right here. Then we have another one at x equals 2. And we have another x-intercept at negative 5. Okay, bear with me. I'm using my fingers, so that's why I'm not getting accurate points. But you would put one at each corresponding number. Now to find my y-intercept, I let x equals 0, so I just plug it into the equation here. So I'm going to say y is equal to, and for every x I'm going to put a 0. So 0 plus 1 times 0 minus 2 times 0 plus 5, which would result in 1 times negative 2 times 5. So our y-intercept is at negative 10. So we're going to plot negative 10 below here. Okay, to plot this graph, we need to know what kind of graph this is. So I could see from my equation that I have 3 x's multiplied together. So this is a degree 3 polynomial, which means it will start from the bottom and it will go up like a snake. So basically from my graph here, I'm going to do the same thing. I'm going to go up from the bottom, go through the x-intercept, go up high, we'll check that point later, go back down through the y-intercept and back up through the, through the x-intercept. Okay, so I am drawing with my finger, which is why it's not coming out as nice, but it loops through every point. Okay, if you want to know exactly how high this graph goes right here, then, well, you would either use a graphing calculator or you can just check. This is the point where x is negative 3. So all you need to do is plug in negative 3 into the equation. When I plug in negative 3, I would get negative 3 plus 1, that would be negative 2. Negative 3 minus 2, that would be negative 5. And negative 3 plus 5 would be positive 2 multiplied all together, and you would get positive 20. So this, I'll erase this right here, would actually go up to positive 20, which would be approximately here. Okay, why is it not drawing it? Okay, so looking at the graph, it would go up to positive 20, back down through the next x-intercept, loop through the y-intercept, and go up through the third x-intercept. And there's our graph. Okay, last thing we want to talk about is end behavior. So basically we're going to look at the left side of the graph, and we're going to look to see which direction the graph is going as x is going to the left. And we could see that right here our graph is going down. So what we're going to write is as x goes to the left, we write it as x goes to negative infinity, y goes to negative infinity as well. And on the right side, right here, we could see that as we are going to the right, we say as x goes to positive infinity, y goes up, which is positive infinity. So this is up, this is right, x goes to the left here, and y goes down. Okay, try this one. Okay, let's look at the second one. Sketch a graph of f of x equals x times x minus 3 times x plus 1 times x minus 2. So I already set up y equals 0 and all the factors. Be careful right here for this one. This first x, that is also a factor, so I must set it equal to 0. And I get 4 real roots. So we're going to put those 4 real roots on the graph. Okay, so right here I have x equals to negative 1 is a root, x equals to 0 is a root, x equals 2 is a root, and x equals 3. So you should have 4 points on the graph. Next, we're going to find the y-intercept. So we're going to let x equals 0, and we're going to plug in 0 for all the x's in the equation. So that would result in y equals to 0 times 0 minus 3 times 0 plus 1 times 0 minus 2. Well, it doesn't matter what these are here, because as you can see, I have everything is in the end going to be multiplied by 0, so that would result in y equals to 0. So that is a y-intercept. So we have an x and y-intercept at the same point, 0, 0. Now this graph is a degree 4 polynomial, because you could see that when I multiply x times x right here, x times x times x times x, I'm going to end up with x to the 4 graph. So an x to the 4 polynomial graph is some type of W shape where both directions are going up. So I'm going to graph this by going through the intercepts, up through the intercepts. And there is my W shape. Now again, how high this graph right here will go, we would need to plug in the point right here, which is x equals 1. So at x equals 1, I'm going to make a little table here. I could just substitute for x1. I get 1 up here. 1 minus 3 is negative 2. 1 plus 1 is 2. And 1 minus 2 is negative 1. So 1 times negative 2 is negative 2. This is a plus 2. Negative 2 times 2 is negative 4. And negative 4 times negative 1 is positive 4. All right, so graphing this again, I would go through the x-intercept here, go up to 4, and come back down. So that would be my point up here. At 1, I would have 4. And again, if I want to know how low these points go, I would have to substitute the values. In this case here, it would be when x equals negative 5, sorry, negative a half, 0.5, and here it would be 1, 2, 2.5. So if you use a calculator or you just plug in the point negative 0.5, you would find that the graph y would equal approximately negative 2.2. So that would go down to here. So we would go down this far. And when you plug in 2.5, you'll get y equals to negative 0.22 again. So this is what your graph looks like. All right, so let's look at the end behavior. We write as x goes to the left, which would mean negative infinity. Y goes up, so we write y goes to positive infinity. And on the right, as x goes to the right, we write positive infinity. Y goes up again, so we write y goes to positive infinity.